Good evening, everybody, and a very warm welcome to all of the students, researchers, and space enthusiasts joining us today. On behalf of Propagation Institute of Advanced Studies, I welcome you to today's session under the Curious Mind series. At Propagation, our vision is simple but powerful: to build one of the largest communities where students can directly interact with researchers and scientists. We believe that curiosity grows when students are not limited to textbooks, but connect directly with the people who are actually building space science and technology. Through our initiatives, students regularly engage with scientists, learn about real research, and explore emerging fields in science and technology. Along with expert sessions like this, the Institute also runs academic programs such as Summer School of Astronomy, Astrophysics, where students explore the universe through structured scientific learning. Our rocket science program, which is currently open, allows students to understand how rockets work, how launch systems are designed, and how space missions are developed. Through these programs, Propagation Institute for Advanced Studies aims to make world-class space and science education accessible to students everywhere. Now, coming to today's session, it is an extreme honor of mine to welcome our distinguished guest and speaker today, Sudheer Kumar. He is a former director of the Capacity Building Program Office at ISRO's research organization, currently vice president at X-ISRO Scientist, and also serves as an adjunct faculty at the National Institute for Advanced Studies. We are extremely honored to have him. We will now pass on the mic to him so that he can continue with today's speaking. Thank you, sir.
Thank you. Thank you. Thanks a lot. Hope I'll share my screen. Just confirm to me after that. Hope it is visible.
Yes, sir. It's visible.
Yeah, thank you. Thank you, viewers online and from Propagation Institute. Such kind of endeavors, what it creates is first is enthusiasm, of course, for sure. But on the other hand, it also creates some kind of synergy between the like-minded people, how they plan their career and future for the needs of the country, not only country, for the global community also. So is this small screen is visible or the entire thing is visible? Ma? Can you just confirm, because I am seeing a small screen of video.
So small screen
is visible.
That is also visible, is it?
Yes. If you cut this, then it will not be visible and won't have a problem.
Now it's okay?
Yes.
Okay, fine. Space. Space is now, so far, space used to be very niche technology, niche area. Only very few organizations like government, they use this technology or they use this particular domain, and it is very restricted. And many people do not know what's it, except that rockets and satellites the scientists are launching, and some kind of, let us say, astronomy related to things. But of late, as the needs, as the crisis is becoming more and more, probably I think everybody looking for a new technology or new solutions where we find solutions for the common thing. On the one hand, the crisis is getting increased. This is all social life crisis, I should say. Population, temperature, migration in the biosphere, consumption of natural resources. Today, you are seeing lots of fights between the countries, even half of the entire globe, if not half, even more than half of the globe is indulged in or involved in some kind of war. Because of what? Natural resources. The war is fine. The agenda behind the one is fighting for minerals, fighting for, let us say, natural resources like oil, sovereignty protection. Such kind of things are happening. While social problems are there, like depletion of pollution, let us say, wastewater disposal, global warming, let us say, depletion of water, forest fires, which are causing carbon imbalance, deforestation, which is again causing carbon imbalance, mining, exploitation of mining without knowing where actually the resources are available, which causes the earthquakes, drought, imbalance in the cyclone things, imbalance in the monsoon, imbalance in the temperature. See, many things which never, rather our generations felt, now these generations are feeling, and it is on the rising trend. What to do? What to do, especially the next generation people who are maybe at around 15 to 20 years age. By the time they become adults and they become started earning, so lot more many problems are going to come. The solution is only technology, because the natural what you call adjustments have taken place already. We have crossed a limit where the nature will adjust itself, so that the imbalance or the entropy will be adjusted. You take urbanization, entire villages are becoming totally vacant. Why? Because of education, amusement, so many other things. Urbanization is happening. When you come to urban cities, what happens? Resources will not be there, water will not be there, traffic problems will be there, so many, pollution will be there, imbalance in the economy status. Okay. Then what are the solutions? Going for renewable energy, going for some kind of smart systems to take care. Thefts are happening, cyber crimes are happening, violation of rules are happening. For all these things, again, the solution is technology. What is the technology? I can't say that this is a space technology, but it is some kind of bundling of different technologies which will find or which will provide solutions for many social problems. So my topic today could be how actually satellites are going to be useful for us. So what is the future? How actually these technologies can be leveraged? How these technologies can be enabled? How these technologies can be explored, and how these technologies will be exploited for you people in the next generation, people or generations to come, to live peacefully on the ecosystem. While some of the people say that we will go to moon or we'll go to Mars for making colonization, but majority of the people it may not be possible. For us, we have to live on the earth to basic survive to for basic survivability, and of course we can always reach moon and star. So if you see the applications of the space, how actually they are categorized: remote sensing, communication, navigation, science missions, human space. If you take the left hand, let us say if you cut it a diagonal, let us say space missions and human space, they are more for technology driven, maybe finding out the basic fundamental advanced technologies, how actually their spin-offs can be utilized for the social life. But the remote sensing, communication, and navigation, these are all the three basic technologies influencing the life of every common man, Let us spend some time on how these technologies will influence us and how these technologies are going to shape in the futures to come. GIS. This is a very important technology where the natural resources, earth resources, geo means earth, geo resources, whatever is there that you are enjoying or you are suffering on the earth, comes under this particular umbrella. Be it transportation, be it natural resources, be it your amusement, be it your air pollution, be it your traffic management, be it glacier, let us say a movement which will give you water during the summer or all through seasons, being it agriculture. So if you just bifurcate this GIS, what is this GIS all about? It calls for positioning system, positioning technologies. I'm also talking the technologies, use cases, maybe a number of things would be there, which while wherever it is required, I'll just touch upon. If you say, see what is GIS, Geo Information Systems or Services, GNSS, Positional Navigation System, occupies 45% of the entire market. Today, the GIS market, because anything what you do, ultimately, you have to do it for not for charity purpose. You should find something engagement, and you should find something you should get out of it for your survival. That means either economy or revenues or engagements or employment or contributing to the society. So this GNSS is one GNSS, that is a navigation system, which occupies 45% of the entire GIS market, which talks about data visualization, spatial analysis, mapping of urban planning. Because today, if you see, if we go to the any cities, what happens? The gas pipelines is now not through cylinders, through a pipeline. When pipeline is made, how carefully, how safely the pipeline has to be made. It should not cross any kind of houses or electrical installations. There is a sewage system, drinking water system, then electrical pipelines. So many other things are going underground. How actually all this will be managed? This is by this GIS maps. Okay, so tomorrow when you can, it has gone to such an extent, 3D, especially 3D digital twin technologies. When you talk about, huge amount of buildings are there, 24-story buildings, 50-story buildings. One building, whatever the light energy that is consuming, can feed definitely, I'm sure, a village. A village of Indian, this thing, whatever the energy that is consumed, probably that building, let's say it is a Microsoft building, or let's say Oracle building, or any company's building, corporate office building, is consuming much more than a village consumes. You just imagine if saving of the energy is more than producing it. These digital twins or digital technologies are coming in a very handy way, so that when you can map the entire building with your IoT systems, you can save energy, not only sitting here, because you need not to employ so many people. Just within your laptop or your mobile, you can control entire energy using the sensors. The lifts, the toilets, the corridors, where man movement is not there, you can switch off automatically. That is the way the technology is enabling the survivability. Similarly, the big data analysis, okay, location-based servicing, tourism, all these things are coming under this GNSS package, where the remote sensing is something about the Earth data, and GNSS is positioning and timing data. And when you see a superimpose these two things, amazing applications are there, which saves billions of let us say expenditure for the mankind. Okay, and so the projection was there. The GIS market is 40,000 crores by the time 2030 comes. Today it stands at 25,000 crores. And tomorrow, when you can save even 1% of it or 2% of it, you can imagine how many crores of saving would be there. For that one, what is the technology that are required? All being used. But advanced countries like Singapore, Vienna, they have implemented in a very good way. The scope within India, how many as the skyscrapers are increasing day by day in the cities like Bangalore, Hyderabad, Calcutta, Mumbai, Delhi, how much energy you can save, and how these technologies, the known people can get employment, you can just imagine. Agriculture is our basic revenue generation, let us say, domain, which is more than 23% of entire our economy depends on the agriculture. When one side, we do not know how much land usage it is there. We do not know the entire mapping, whether it is a land, or let us say supply distribution system, or fertilizers requirement, or water requirement, or public distribution system. The entire thing can be mapped using smart agricultural programs. Today, the government is offering this their choice using the space data. Let us say you have oranges in Nagpur, whereas demand is there in Arunachal Pradesh. You produce apple is produced in the hilly areas, whereas Kanyakumari has also got a huge demand. So like that, when you map the entire produce and the demand, you can plan your warehouses, your transportation systems, including trains, trucks, and cold storages. And you can plan fertilizers, which plant requires what fertilizer, when it is required as per the season, what time it is required, so that the fertilizers and pesticides would be available in that region during that time. This is called the entire mapping of the resources in the agriculture. This is possible only through technology. Even you are sitting in your own village, whatever the village that you reside, you need not have to go to, let us say, States or Singapore or Middle East or Canada or Japan, Germany for education and what you call employment. If you are aware of all these things, taking one small laptop, you can sit in your own village and you can plan your own resources. So these many things are there which smart agriculture can do. Precision farming, because in a small area, how actually the spices can be built. Because India is the maximum first exporter of the entire world, the spices. When such kind of demand is there, why only few areas can develop spices? Spices could be even cash crops like turmeric, like even fruits like horticulture, like papaya. The alternate sources of, let's say, generating revenue. Papaya is one. You need not have to go only for papaya fruit, let us say, marketing. Papaya milk is directly being used for liver medicines, for generating or producing liver medicines. This kind of knowledge and awareness, when you have, so is a cross-functional, I should say, the agriculture, the medicinal kind of technologies that will superimpose each other and generates revenue and employment for our youth. Forest. It's all coming under GIS. I'm just touching about each and every domain where you have problem and you have technology and you have ideas. Only the people should get connected and build their careers and build their, let us say, ultimate revenues together. Today, the forest is a very important aspect for controlling our monsoon. Today, forest fires are happening, which is not in our control. But as per the FSI estimates, yearly we are losing 440 crores on account of forest fires. And we don't have satellites. We are still depending on the American satellites to the maximum extent for identifying the forest fires. When fire has happened, how to extinguish that fire and how to not to propagate that fire, what are the measures that we have to take, and deforestation to make the same kind of ecological balance, where how actually deforestation should happen, what are the forest produces, how many forest produce, because major maximum our natural elements, even herbs, comes out of forests. This much opportunity is there applying the technology tomorrow to conserve the forest and to bring back the ecology. We need sophisticated technology adoption for all these areas. Urban, I can't tell in the urban planning how many technologies that we can use. In fact, I have listed down the government schemes on the left hand side. How many schemes are there for protecting the urbanization and making the people live happily? If you see urban planning and monitoring, you have a number of problems with the urban, because when a rain comes, traffic will be jammed because proper drainage system is not there. If you can estimate using the technology how actually the rain season will come and how actually you can reroute the traffic, that itself is the biggest thing. Otherwise, people are on the roads in the especially cities like Bangalore, hours, maybe 3 to 4 hours to reach office and come back home. People are spending, it is not an exaggeration, it is a fact, because I myself suffered and I myself experienced such kind of things in peak hours. Okay, water sanitation. If you don't sanitize water, if the water gets back into the public areas, what happens? Entire health will be spoiled. Entire health will be spoiled. And for containing that one, again, medical treatment is required. Okay, proper, let us say, drinking water. Drinking water, when leakage is there, again, water resource, waste of water resource. Based on the satellite images, at least today, we are having 30 centimeters resolution satellite imagery. If any soil moisture happens around that area, you can still identify using the satellite technology. So to that extent, the technology has grown. Even what is happening in your backyard, whether your wet waste or solid waste or dry waste has been lifted or not, using the IT devices and satellite imagery, anybody can control today. Today, we are able to control it. And whether our sanitation problems are there, stagnation of water is there for more than 15 days, again, mosquito breeding, so many the unhealthy health hazards will be there. We are able to make such kind of assessments using satellite data, provided some issues are there, because if it is imaging, when the cloud is there, you can't do that one. When vegetation is there, you can't do that one. So that have to be supplemented with the drones and IoT. That is the reason it's a combination of technologies that leverages us to be more peaceful. Smart cities. Today, smart cities are being built across the globe, where the entire infrastructure, as I was telling you, can be managed from your laptop. Smart building and energy management, transportation and mobility, traffic planning, diversion of the routes, and to make more greenery on the top of the buildings, because people are able to what you call make the hydroponics, and such kind of technologies are now being grown in multiple cities. How to make our lives happy is in our hands. Okay, so some of the things I'm just skipping because of the paucity of time. These technologies will enable us to identify where we can have the renewable energies, even windmills. Where to put windmills is a study being the satellite technology offers. Okay. So many things are there in the EAS. The second technology will go SatCom. SatCom, communications. If communication satellite is not there, you will never get your internet, you will never get your mobile, you will never get your DTH services. But apart from that one, there are a number of other services like your meteorological services, your telemedicine services, tele-education services. Those who are there in the hilly areas, they will know how actually a difficult situation will come in a hilly area when some lady delivering a baby, newborn baby, which is not in their hand, to come to the rescue. If they have to reach the nearest, let us say, hospital, it takes minimum 4 to 5 hours. That too in hot roads they have to travel. If a small doctor is there, and he will take help of the baseline doctor, and when he guides, he can always look into the reports, and he can always take the help of the thing. Such kind of models exist. Mobile satellite services is growing day by day, especially the Starlink's program. When it hit the world's market, the number of services that are being offered using mobile phone is increasing like anything. If you have mobile in your phone, you can book your tickets, you can do all your banking transactions, you can book your entire thing, you can know where you are going, you can talk to your friends very freely wherever you are across the globe. Such a kind of advancement has happened in the mobile services. Tomorrow, that the day is not very far, directly your mobile phone is going to be connected to the satellite. So even if you are in the middle of the sea, as long as you are in a region on the earth, you can still get connected to the entire world in a very better way. But at the same time, these technologies at a very affordable prices are available for the communities like fishermen. If I say, we as an ISRO, we are putting some kind of digital alarm systems on the boats. When they go out of the international waters, out of the national waters, it gives an alarm. When they are exactly the position, it shows. When something has happened, if they just press a button like emergency system, a signal will go to the nearest, let us say, landmark control center, where they will identify that this particular boat is in danger, and immediately Coast Guards or whoever is the rescue teams, they will go near to the boat, and they will rescue the people. So such kind of sophistication has now come in the technologies. Let's say in India, you just see how many boats are there, how many fishermen are there across the 8,000 or 8,500 kilometers of our coastal line. Many people, you may be near to the coastal line. So if you just go and develop a small technology and offer to them, this is a revenue model. And in fact, for some of the startups in the Mumbai, they have worked maybe 4 or 5 years back. The technology, I hope now, should have propagated to everybody. They have developed an app using the GNSS signals. When the fisherman loads how much catch he has done, and he immediately transmits that message to the earth, to the land. By the time they come to the seashore with the fish catch, the entire let us say, the supply chain system, whether it could be Zomato or the Amazon Fresh, such kind of people with the freezers to take fresh fish into their storages and pay the fishermen then and there online. So such kind of system, now technologies have come. There is no requirement for storages. There is no requirement for mid storages. There is no requirement of transshipment again from seashore to another storage. Stay there. Even people will get fresh fish. So such kind of provisions are now happening with the technology. Mobility, mobile services. Mobile services is satellite mobile services is really helping the essential emergency treatment, especially when the people are there on move. When they have a satellite phone, even today, the hospital systems, ambulances are equipped with such kind of mobile services. In case of any emergency, they can still reach, even wherever they are traveling, they will reach to the nearest rescue system through that satellite phones. Navigation, I can't explain how much technology penetration is there and use cases are there in navigation. And without navigation, I don't think it is basically time, which is put the stamp of a time. Wherever you are, let us say, if you know the location, is not enough where you are, at what time you are, when you will reach the other station. And globally, you have different types of navigation systems. GPS, which is very popular, which is very widely used by the people. Russia has got GLONASS, China has got Vidu, and Galileo is the European agency's system, which is used by all European countries. QZSS is the Japanese local system, like our NavIC regional system. Okay, using these things, Honorable Prime Minister of India has launched, named this by IRNSS, we used to call it as earlier, Indian Regional Navigation System, is being named as NavIC. We call it as NavIC. NavIC is a very, very powerful tool in our region to locate everything, whether it is in the air or in the land or in the sea. And this system is can be used by many users like replacement for GPS, but the technology has to grow and number of satellites have to grow, and the mobile services people have to implement this particular technology to their mobile sets. Otherwise, NavIC as a standalone cartridge, it is available for putting into the cars, any kind of vehicles. Okay, using this NavIC system, we are able to track all whatever the train information system that you use on the apps. This because of the NavIC. And air, because if you just type flight tracking using this kind of navigation systems, you will track even aeroplanes, even boats. That's what I was telling you. The boats, entire thing, you can track it. The ultimate next generation, what is the future technology, is satellite phone. Not only satellite phone, the chip which we do on the left hand side, you will see we have developed a chip which will rather amalgamate the technologies and data and protocols which will be used not only for GPS, GLONASS. If a common chip is there which will adopt all these technologies, if the chip can be used in your mobile phone, the way you are using the GPS, the same way you can use our NavIC also. I think this being discussed across with all the mobile manufacturers, it takes some time because it is a technology being operated by other nations. Now I have come to the very, very, very important area where this particular technology is used for our self-defense. You have seen Operation Sindoor. You have seen the way recent that Iran was happening, Israel war has happened, and you have been seeing Russian-Ukraine war. Now wars are being controlled not by tankers or not by the soldiers. They are by flights and they are operated by the satellite technologies. The satellite identifies the enemy, and it directs the fighters and fighters will go and bombard them and come back, or a missile, they will feed the information. How to feed that information is a question. How actually we will know sitting here, maybe how do we know our enemy maybe 500 kilometers or 2,000 kilometers away? The technologies are available. These technologies are called ELINT technologies or SAR technologies or EO technologies. You see, EO, Earth observation, is basically a passive kind of optical systems which will be in the satellite, which works on the remote sensing technology. When you throw some signal, optical email, the signal, and it goes back, reflects, and it goes back and captures by sensor and gives either a direct image or indirect image. But the problem with Earth observation satellite, imaging satellites or optical satellite is it cannot penetrate. When a cloud is there, you can't take an image. Okay. So the SAR synthetic aperture radar is a technology where the signals will pass through clouds also in a different in different wavelengths, and captures the image and put it back to the controller. But let us say now the question is, when you have a cloud, you will get the IR image like SAR image. When cloud is not there, optical image. So if you fuse these two things, because you have a history data, what kind of image was there when the cloud was not there in the previous past you have. So if you fuse this data using artificial intelligence, you can make out what is the stuff that is there, because this is a very complicated technology, fusing of Earth observation in SAR data. But if we can fuse, now we have launched a satellite recently. Galaxy is going to launch a satellite, which is this fusion, which is first of its kind in the entire world. If you can fuse this data and come out, it gives you the perfect image of anything, all weather, whether it is cloudy or whether you don't have the proper light to take the image you have. So these are all the new technologies that are emerging to protect. But in addition to that one, ELINT is a technology, electronic intelligence, where we usually call it as SAR and EO are eyes and ELINT ears in the sky. So when you make these three technologies, especially for defense, what happens when some signal or something like that, it is identified, the electronic systems, the satellite will intercept the RF emissions and find out where the radar is, where the electronic systems are. Basically, these are all the control rooms or the control systems which operate the flights or which operate different, identifies the enemy planes. Let's say if you bombard them, what happens? The enemy will not have any control. Where from the missile is coming, where from the fighter jet is coming, what to do, how to track, and how to react to neutralize those things, the enemy will not. Now the question is, it's not that what you call killing the target or killing the what you call this one, but if you kill a kind of, let us say, a control system which controls the entire thing, it is as good as killing the control weapons. So this is called ELINT technology, which is now has been used very widely in all these in all these let us say wars. Yesterday you have seen Iran has bombarded all the radar systems, USA radar systems in different countries. The USA has bombarded many kind of the control systems in other countries. This is where the warfare is now changing the entire landscape of this fighter. So when you have these three together in a satellite, you just imagine then that satellite going to be, how powerful that satellite is going to be, is a new technology which people are working today to put all these three payloads in one satellite and simultaneously gives the command to the ground systems and ground control centers, so that the warfare, whoever is sitting in the control room, they will take proper decisions. And similarly in the electronic intelligence, we have signal intelligence, where our interceptor signals will be whatever the signal it could be, even it could be E-band signal or any signal, it will intercept and try to tell you that, look, there is an intelligent system which is trying to sit in this location, and you can kill it. And COMINT, voice and data communication also plays a major role. That is where in the Operation Sindoor, when the terrorist has just switched on the phone and try to reach someone, we have intercepted that one and we have we have neutralized those people. This is called COMINT. And ELINT, radars and electronic systems emissions, when they do, because each and every radar emits radio frequencies. When it emits radio frequencies, when you just cuts across the emissions, you can find out where from these emissions are coming and fix the location using your own intelligence, navigational intelligence, and fix the location for sending either a fighter plane with a missile or from land to land missile, ground to ground missile. This I just compiled the ELINT, communication intelligence, signal intelligence, electronic intelligence, communication intelligence, and signal intelligence. These are all three major players. USA has got more than, I should say, 100 to 150 satellites to operate all these technologies around the clock. That is how it is superpower, and it is winning the wars. This is the technology I was imagining. If all these three things are fused and put together in one satellite, it is, I just created all these things using ChatGPT. Let me be very fair. Within 1 second, I am able to speak to you showing the images. How useful the technology is all about. This is what artificial intelligence all about. Okay. Then when it comes to the layers of the thing, another technology is now being talked about. It is not enough if you keep a satellite in LEO. Why? Because the LEO, every let's say if it is in the 500 kilometers orbit, the satellite moves around 19 times in a day. But what happens if 19 times means hardly, you can say 1 hour or a little bit more than 1 hour? What happens remaining rest of the time? So to have a complete eye on a particular location, you have to go to geostationary satellite. But problem with geostationary is, since it is 36,000 kilometers, your response is very low, and your signal strength and high throughput, big satellites you have to keep. So that is why now people are coming out with solutions. Some more number of satellites we will keep it in the LEO, and medium number of satellites we will keep it in MEO. MEO means medium orbits, somewhere between 1200 or 1500, leaving the Kuiper belt, up to 25,000 kilometers. And 36,000 kilometers, you have to have geostationary satellites. With these combinations, three combinations, what happens? You can be very perfectly, you can work and get to know the 24/7 information in a very meaningful way. So I thought I have spent sufficient time for the satellites and technologies. Let me just talk about what is happening in India, within India, how our roadmap is, how our technology roadmap is. Maybe we are sitting in 2025. We are now working on the Gaganyaan. We are now, as far as the satellite technology, launch vehicle technologies are concerned, we are increasing our capability to reach at least 50 to 60 tons to the ISS. That means around 400 to 500 kilometers. And big spacecrafts to geostationary as well as to the moon. That was the mandate has been given to ISRO by Government of India. We are working on bigger satellites. Reusability is another thing to make the launches very affordable for multiple applications. That is, vertical takeoff and vertical landing is the thing for the transporter our Elon Musk has demonstrated. So that is the technology is now being pursued. High speeds, like I say, if you wanted to carry out the moon, the Mars mission or Sukran mission, Conventional propulsion, conventional thing is not enough. We have to go to air-breathed engines, because it will go to hypersonic and much 10 times the speed or 15 times the speed. The rate of change, the travel would be there. For that one, air-breathing engines are being worked out. Uh, so that is on the launch vehicle front. When it comes to the satellite front, all our satellites, we are now going for technologies what I have explained so far. High throughput technologies for internet. We are now going for Chandrayaan 4, Chandrayaan 5, Bharatiya Antariksha Station, and space explorations, exploratory missions like Mars and Sukrayan. So this is on the roadmap, but technologies are required. It's not a joke. Conceiving the critical technology, it takes years. It takes a huge amount of manpower also to work on these technologies. This is what I was explaining you. We have Chandrayaan program, we have Gaganyaan program, we have launch vehicle program, next generation launch vehicle program. To reach, the idea is to put the man on the moon by 2040, and by 2030, that time frame, we have to start the building the International Space Station of our own, that is called Bharatiya Antariksha Station. For that one, lots of activities are going on. Again, I was telling you, because many people, ignorant people, they may say that why it is taking a lot of time to get a sensor, to get a let us say identify a sensor. How actually there are 230 sensors which are required to make the program very successful. If a person is living in a small capsule of hardly 5 meters by 5 meters, let us say the human capsule, if he has to be there for 7 days, how many requirements would be there? His entire biology has to be controlled. His comfort levels have to be controlled. His anatomy has to be controlled. His entire body parameters have to be controlled. And if in case of anything, first is he has to be secured. Second thing, he is to be monitored. In case of anything, he should be controlled on its own. How much sophistication that is required within the capsule is very important. In case of something has happened, how to get back is another important, during the launch phase, during the ascending phase, and during the orbital phase, and during the re-entry phase. And these are all the technologies which we don't have readily available at an affordable cost from any nation. That is the reason we are developing testing, because n number of tests is not enough. One test if you do. So multiple testing we have to do, that consumes time, and we are very much on the right track to achieve these missions. And future lunar missions, robotic missions, in-space manufacturing, whatnot, propulsion systems, advanced propulsion systems, advanced imaging systems, advanced control systems. Many are happening, because if you go to the moon and make the colonies, you can't take mortar and bricks from the earth. You have to consume the same material on the moon and make it habitable and make it, let us say, constructible, and you have to construct your own houses over there. If it calls for some kind of temporary accommodation, like inflatable structures, like temporarily conducting the experiments, such kind of new technologies are now being deployable structures, inflatable structures, and in space manufacturing. Use a robo, take the what you call different elements from the local region and convert it into a usable what you call physical item. These are all the technologies are being pursued at different locations, at different IITs and different labs. These experiments are happening, so that in another decade or 2 decades, we'll equip ourselves with these new technologies. This is the Bharatiya Antariksha Station. It is a very complicated station where people have to go and do experiments, even for them to sit, for them to take bath, for them to take sleep, for them to go for natural calls, for them to take let us say communication, entertainment. So that, because if you are alone in a house, you just imagine you'll go mad. The psychological factors are very important for an astronaut. How to keep him busy, keep him more let us say mentally healthier is very important. That the Bharatiya Antariksha Station will provide all these things in a very what you call safe and secured manner. I was telling what are the advanced technologies. Now people are talking about asteroid mining. Apophis is the asteroid which is coming near to the Earth in the coming years, 2 to 3 years. People are working how actually we will fly our satellite, understand what the technology, what the minerals, and what is the things that we have around. And hypersonic aviation, I was telling you, to go to Mars and come back, these conventional rockets will not be enough. It takes years to go to Mars and come back. Okay, cislunar development. This cislunar development is between Earth and the Moon. This particular thing we have to have very comfortable stay, go and come back. How actually what is the best method to go to Moon and come back? That is another technology. For that one, docking. So many techniques are required. Space factories. If you wanted to manufacture some kind of, let us say, oxygen or water to feed to the ISS station, we have to have our own factories. It is not enough if you keep on supplying the water from the Earth to the transportation cost will go up. Let us say 10,000 people are let us say staying on a moon in the years to come. How to feed their food? How to take out their waste? These are all the technologies people are working. Scientists are working. Probably, I think all of you, when you grow up in the thing, and when you become, obviously we look for uh, some kind of let us say you people are all becoming scientists and developing this technology. We look for such kind of instant. It's only a motivational lecture, I should say. I just shown you some of the things in a very crispy and abstract manner. Everyone have to pick up these words. You have to do your own research. You have to do your own search and research to become a scientist, either directly or indirectly, to contribute to the ecosystem and to make your lives and other lives very happy. Thank you. I leave 10 minutes for question answers. If at all anything is there, we'll sharply wind up by 7 o'clock. Thank you.
Yep. Thank you so much, sir. We'll take in some questions now. People can raise their hands if they have questions. Also, a few instructions for you. Raise your hands and open your mic and camera when you are to ask the questions. Okay.
And there is some time issue as well, everyone. So because sir has to go somewhere. So if you have any doubt, just don't worry about that. You can just send us on propagation.connect email. Okay, we'll definitely answer it. Okay. So if you have any niche questions, okay, from the space science and technology, you just raise your hand.
Ashutosh, you can go ahead and ask the question. Please open your mic and camera and you can go ahead and ask a question.
Yeah, go ahead.
Hello.
Yes.
Go ahead.
Hello. Hello. Good
Good
evening,
evening.
sir. Myself Asutosh Sintomu. I am applied geology student at NIT Rourkela, MSc first year. Sir, I want to ask you that how a geology student can enter into a ISRO or as a geologist.
See, please, for all the participants, I'll tell you one thing. Please don't expect that ISRO only doing the job. Okay. As a geologist, why you should enter into ISRO? You should ask me a question as how the space technology will be useful for geology, so that I will learn something and I'll put my knowledge into the domain utilizing this technology. That would be the right kind of question. Why ISRO? Why can't, if you get 2 to 3 times of the salary outside, do you prefer ISRO? Please stop asking these questions. ISRO, you can join always. What is there? If you go to Google, ICRB is the exam. If you just write the exam, you will get into. Please don't ask such kind of questions. I prefer you to ask me as a geology student how I will contribute. That is the correct question. Okay. Today, for minerals, people or countries are fighting. It's all geology. How actually earthquakes are happening, how water fault will be identified in hilly areas to get drinking water. I'm telling you in Tirupati because this was a real story which we are doing when they are starving for water on the uphills, when they did not have any solution except for depending on the rainwater. Our scientists, geologists, and our remote sensing scientists have gone and found waterfalls beneath the hilly layers, and we found out water resource at maybe 2,500 feet above the ground level, and found out a water for Tirupati. This is the space technology you should talk about. Minerals, we have found out very rare earth minerals because IIT Kharagpur, when I was having a review meeting, there is a very precision metal we have found out, a research scholar has found out, and in the regions of, let's say, Burmese and that area. Because please identify, there are extra spectrometry kind of data available across the thing at free of cost. Please do some research to identify the rare earths, the potential, let us say, zones of these kind of precision materials. Do a study or launch a satellite to identify your spectrometry. Develop a payload to identify mineralogy. That is how your contribution should be. This is order of the day. World is fighting for rare earths. Please, in India, lots of such kind of materials are there in the seabeds, in the hilly areas, in the folding faults. That I need not to tell you. Please contribute that one and identify the rare earths within India.
Okay, sir. Thank you.
Ashutosh.
Thank you.
All right, we have Prince Kumar. Prince, you can go ahead and ask the question. Please open your camera and you can ask the question. All right.
Hello.
Yes. Good.
Am I audible?
Yes.
Go ahead. Please go ahead. Fast.
Sir, good evening. I want to ask that how can I contribute as a computer science graduate to space tech?
See, just now, whatever I have explained you using artificial intelligence, you have picobytes of data. When some kind of, let us say, example, defense, I told you already as an electronic intelligence. Near real time decisions are very important for anybody. Let us say you have a past data. If you tells me, I will give you the solution after 2 days, what is the use? This is where the computer science persons will have maximum number of engagement, whether it is mission software, which takes the satellite onto the earth, or controlling the data and processing the data either on board using the edge computing or artificial intelligence or machine learning, deep learning techniques. When the data comes back, processing the data and giving the solution decision. Because if a missile has to fire, missile will reach 4,000 kilometers in a fraction of a minute. Within that minute, you have to provide the decisions to that control system where this location is. The precision let's say it is an intelligence systems on board. It requires the entire firmware, entire the edge computing software will be onboarded. It all happens only through computer science and your languages, your control systems. Okay, and you have enough domain, whether it is building information system or making the digital things for civilian applications and ultimately making a what you call the dynamic signaling system for traffic management. Everywhere the electronics and computer software is only there. Please make use of it. Please identify, explore the knowledge using the case studies.
Thank you.
Lakshmi has a question. She says you mentioned about satellite and all the applications, technology, etc. But what about space junk? It increases day by day, and chances to harm the escapes, telescopes, and all is increasing. How can we manage space junk?
See, we call it as space debris.
Yeah.
The space situational awareness is the technology which controls the debris, not controls the debris, which monitors the debris. We call it as whenever active debris, there are two kinds of debris, active debris and passive debris. Active debris are working satellites. Passive debris are either dead satellites or dead stages or anything which are not working. The more danger is between active debris and passive debris, because passive debris doesn't have any control. It will just go around. But from the using the telescopes and using the multi-object interactor radars, what we do, the enough cataloging of each and every object which is 10 centimeters above has been done by agencies, mostly USA agencies. They'll be tracked 24/7. The Leo Labs, such kind of agencies are there, which they track using the satellites. And we have our own mechanism. We have telescopes and we have multi-object tracking radars. What happens when two objects are likely to collide? We call it as collision avoidance mechanism, CAM. We, using the thrusters, we will bypass the, it is like a road, in the road two cars are going. When an uncontrollable fellow is coming to hit you, what you do, you just divert it and take a direction. So this is called exactly collision avoidance mechanism, collision maneuvers we call it as. So these collision maneuvers is the 24/7 work of a satellite operator to protect his own resources. But thing is, we have to get back the debris to the earth or fire them in the sky. The technologies are now being developed. We don't have any full-fledged answer for this one. Then regulations are coming. Basically, whoever we have done, let's say megascopic, such kind of satellites, when they outlived the life, we have fired and we have brought the satellites into the atmosphere. When it comes to the atmosphere, maybe 100 to 200 to 300 kilometers, fast it will come to the atmosphere and they burn themselves. If it is a geostationary satellite, we'll fire them up to say, send to the graveyards. This is how the planned debris mitigation is there. But the thing is, live satellites, when they are going in the orbits, we have to find out whether any threat is there with other satellite, with other active debris. We take maneuvers, we execute the maneuvers and save our our assets. But problem with rogue satellites, some of the countries, they come and try to hit. It has happened. It has happened with China. Such kind of satellites has happened. So for such kind of things, we have to bring such kind of events with evidence onto the international fora, and they should know that we are monitoring their satellites also. Okay, there are a number of mechanisms to safeguard our assets, and now debris mitigation and debris management and debris bringing. Many people are working on nets. Many people are working on robots. Many people are working on different technologies, sails. Because if a sail is attached to the satellite, and that satellite will reduce the velocity and comes back. Different technologies. These are all another area which I have not touched upon. Probably if I touch, another 1 hour it will go. We will see in the next session somewhere. I will talk about in detail.
All right. 7 now. So can we take another question? One last question.
Yeah, no issue. Please.
Ask me. You can go ahead and ask a question.
Am I audible?
Yes.
Yeah.
First of all, sir, good evening and thank you for the session. Thank you, Propagation Institute, for this amazing session. So I had just one question. With the rise of private companies like Skyroot and Agnikul, like the opening of the India space sector, like how do you see these startups shaping the future of India's ecosystem? And like what opportunities for us as a mechanical engineer exist for young engineers like us to build organizations in this field?
Good question. Useful question for many people. See, look, people say it is rocket technology. It is not. It's a rocket technology. Okay. First is qualifying the systems, especially launch vehicles. See, if it is application, if a software guy sits and within 1 or 2 months, he will bring out a algorithm or an application program. If it is a satellite, some hardware are there. It will take maybe 12 to 18 months to bring out one satellite if they have good systems. But rocket is not like that. Okay, rocket involves thousands of technologies. It could be structural things, it could be control systems, it could be propellant systems, it could be separation systems, it could be again composites. The technology is not easy to build because ISRO has taken with maximum manpower tens of years to build a rocket or to build a new rocket. Okay, so when the ecosystem comes, the beauty of it is It is not that one ISRO or one Agnikul or one Skyroot is developing the thing. It requires an ecosystem. It requires tier 1 partners, tier 2 partners. Let us say there are 1 lakh fasteners that are required. Who will make it? A propellant is required, 3 types of propellants and hundreds of tons of tons. Who will make it? A transportation is required to move from factory to launch pad. Who will make it? Assembly people are required who have to assemble this launch vehicle. Maybe 200 to 300 people are required. Who will make it? So these are all the spin-off jobs for the youngsters you people have for producing. Structures are there. Let's say metallic structures are there. Even materials development is there. Somebody has to work on machines, okay, to form the structures, to form the motor cases. Composites are there. Control systems are there. Electronics are there. Programming is there. Over and above all of these things, operation and maintenance. Okay. So definitely the youngsters will have, I can't say that lakhs of jobs will be created. But when you work there, you can come on defense technologies. Today, missile takes birth from rocket. Today, the amount of missiles export that is happening, it is amazing. And countries, the global requirement of such kind of defense systems are ever growing after these dirty wars. Okay, so these are all spin-offs. Okay, definitely you should have an interest. Definitely your career can be built around that.
Yes, thank you, sir.
Okay, thank you.
Thank you, Ashley. Thank you so much, sir. We have a very sincere time constraint, so we'll end our session here.
I had one question. I would like to
Yeah,
ask.
please.
Okay, so currently I'm being able to see there is a lots of specific coming up, and there is a lots of specific, as you already do know, they are claiming like they are just going to build the reusable rocket, and they are being able to raise the funds and all, and definitely there is lots of players, so you already do know about it. So I just want to know how much it is like going to be tough from launching a sounding rocket to building a reusable rocket.
See, first thing is there should be a business model, because economy, see, technology, there is no dearth of technology. Okay, there is no dearth of technology. If you start working and if you go around the world and if you go around the people, there are enough people, they're all physics, physics and mathematics. But the question is, developing a technology is not based on the capability. The developing the technology is based on economics. Why many people ask me this question, why ISRO has not developed the reusable technology? It is nothing. If you work for 2 to 3 years, you will develop this one. This technology is nothing for the engineers and scientists. But the thing is whether it is a requirement is there and the economics. If let us say Elon Musk has got an order for ISS for let us say a couple of billions, he has to use the technology, otherwise his economic model, his business model will never be viable. That's why he has developed. But today, for operating a couple of launches, if I go for reusable technology, what do you do with that technology? They should be usability, Okay, so the timelines and other things that are based on the necessity. Today, when we go for Bharatiya Antariksha Station, when we want to have multiple rockets in a year, yes, reusable technology is required. When you can retrieve the rocket within your boundaries, it is not expendable. Let us say if you launch a satellite to, let us say 900 kilometers orbit or 1000 kilometers orbit, 2 stages will go beyond the 500 kilometers so that you can't retrieve. Only those who are just in 100 kilometers or so, you can retrieve back. Okay. And second thing is when it falls in the sea, maybe 200 to 50 kilometers, 250 to 300 kilometers away, to bring back that stage using ships, how much cost is required vis-a-vis the refurbishment cost. If the refurbishment cost is huge than the recovery cost, why should I go for it? Okay, so this technology is not the impediment here. The economics are impediment here. The necessity is impediment here. Okay, and when that necessity comes, anybody, technology development is not a major concern at all.
So after looking out all of the plans as you just shown up the ISRO, sir, so if there is any company who is building the reusable rocket concept, and if they're just going to build in 5 to 6 years,
Yeah, many, no.
It would be great opportunity for them.
No, many people, their roadmap is going for reusable rocket, but in steps. Okay, in steps. First, they have to work on the propellant, which takes the rocket up. Then the propellant and systems to bring the rocket down. First, they have to forward journey. When a forward journey is there, then only reverse journey. No.
Reverse journey.
Okay.
Okay. Okay, sir. It was really nice. Thank you so much. Thank you so much for your answer.
Thank you.
Sir, what we actually usually do is like in the end, we just capture this moment, like we just take some screenshot. So I'd request everyone, please turn on your camera. And if you still have any doubt, everyone, you can just mail us to propagation.connect. Okay, we'll definitely answer you all. So everyone, please turn on your camera. I would request everyone to please turn on your camera.